ThingWorx Neuron is a powerful capability within the ThingWorx platform. It uses machine learning technology to automatically deliver predictive intelligence for smart connected solutions. Now let's take a look at a live solution that was built on the ThingWorx platform, designed to deliver predictive maintenance on smart connected products. The first tab is a dashboard that will help service managers and technicians better identify problematic machines and prioritize service for their smart connected devices. Typically on a dashboard, a user would see some basic analytics about their devices, such as device descriptions and historical readings from logs and sensors. We've included this type of information in this dashboard. However, when ThingWorx Neuron is operating behind the application, it is able to analyze all of the historical data and automatically begin making predictions, in this case for machine failure over the next 30 days. Each individual machine is analyzed, and a determination of failure over the next 30 days is applied to the heating element, pump, and grinder. Now let's say you're a service manager or technician in the Philadelphia area for this company. You can see the machines in your territory by clicking around on this map in the dashboard. By clicking each machine, you can quickly see the risks that each has of failing over the next 30 days. This will allow you to more proactively plan your maintenance on these machines as you are visiting accounts or notifying your operators as to machine conditions. Furthermore, ThingWorx Neuron automatically provides contributing factors to each risk. So as you can see here on this machine has a very high risk of grinder failure, machine 369454, and the contributing factors are listed under here. This will allow service managers or technicians to identify which factors and corresponding values are driving machine failures over the next 30 days. We could use the other ThingWorx capabilities such as alerts and notifications to automatically notify managers, techs, or operators of potential failures before they occur. Now that we've seen what predictions ThingWorx Neuron is making, let's learn about how it's actually created those predictions by clicking on the Prediction Model Statistics tab. Here we are able to see the confidence ThingWorx Neuron has in the models which it's created. For this specific solution, ThingWorx Neuron has created 3 predictions for failure over the next 30 days: heating element failures, pump failures, and grinder failures. Estimated model accuracy represents the confidence in which ThingWorx Neuron has in the model it's created. For heating element failure, it's 98.36% confident in its model. For pump failure, it's 97.68% confident. And for grinder failure, it's 92.93% confident. On this screen, we're also able to see which techniques were used by ThingWorx Neuron to create its predictions. While the predictive capabilities built within ThingWorx Neuron do a great job of identifying individual machines at risk of failure, smart connected product manufacturers and operators can use machine learning to understand important predictors and conditions of failures across their inventory of smart connected products. These insights are informed by looking at all of the devices within a connected ecosystem. This information can be found on the Learn About Machine Failures tab. The first thing you will notice on this tab is that the machine learning technology has analyzed interesting factors driving heating element, pump, and grinder failures over the next 30 days. The first thing we're going to look at is predictive signals. Predictive signals are which factors or categories of factors were most important to ThingWorx Neuron as it created its predictions. For this specific example, we'll look at grinder failures and the predictive signals that are associated with it. We can see here that usage and service are strong indicators of grinder failure over the next 30 days. Now, if we click on each of these, we can see that there's a chart below the predictive signals window. This chart provides us with strong justification as to why it found that usage over the past week was so interesting. As usage increases, so does the probability of grinder failure over the next 30 days. Inversely, let's look at a very weak signal such as boiler water level. We can see here in the justification chart below, boiler water level is flat. Therefore, it's not very predictive of grinder failure over the next 30 days. Moving to the right-hand side of the screen, we begin to see that the machine learning technology has grouped together features within the data set that it found to drive substantially higher levels of grinder failures over the next 30 days. Overall, we can see that machines have an 18.66% chance of grinder failures. However, when we start looking at these combinations of features, we can see a progression towards a much higher failure rate. For example, let's look at an interesting grouping of factors that ThingWorx Neuron has found. So if we scroll to the top here, we can start looking for an interesting set of factors, and I think I found one right here. So if we look at this grouping right here, we see that average daily cycles over the prior week of being 377 to 404. What this basically means is the number of times the machine's been used in the prior week, and this looks to be a pretty heavily used machine. And this is going to equate to about a 78.2% chance of failing. Now this is a pretty large jump over the average grinder failure rate of 18.66%. However, if you add another dimension into this, we see even higher failure rates. If we see 3 to 4 priority service calls in the preceding month, we see a jump to 93.5%. Neuron has found roughly about 308 records within the data set that have both of these factors. As you add two more features, a twisted flange and a satellite grinder, or a grinder that's not integrated into the actual housing of the espresso machine, we get substantially higher failure rates of 95%. And there's roughly about 219 records within the data set that have all four of these features. Knowing these combinations of features and their buildup to substantially higher failure probabilities can enable smart connected manufacturers and operators to better identify manufacturing defects, refine services, processes, and procedures, and proactively train technicians and operators to avoid product failures. By using the ThingWorx platform, smart connected product manufacturers and operators are able to understand critical predictors of various machine failures to improve service plans and future products. They're able to shift their machine service strategy to be proactive and keep operator facilities running smoothly. They can enhance their manufacturing processes to improve upon faulty processes and parts from suppliers. Also, they can educate technicians and operators to understand how to better service each individual machine to prevent predicted failures. And finally, they can share services best practices amongst operator communities based on usage conditions, real-time monitoring, and other dynamic factors. By having the insights and predictions that were automatically generated by the machine learning technology inside of this smart connected application, manufacturers, operators of smart connected products can gain deep insight into how to better service their products, manufacture more efficiently, and ultimately keep their customers happy.